Welcome, and thank you for joining this webinar. From Connectivity to Understanding, the Semantic Future of AI Communications, prepared by the Alpert Research Team. Understanding semantic communication, or SEMCOM, is a strict strategic imperative. It literally represents the foundational shift required for the networks of the 2030s. If we intentionally stop measuring whether every single bit arrived perfectly, doesn't that shatter how we evaluate success in telecommunications?
That is the exact friction point the entire industry is wrestling with right now. Technically, yes. Under the classical rules of telecommunications, throwing away parts of the original file means it is a corrupted, failed transmission. And to understand why the brightest minds in wireless are suddenly perfectly okay with corrupted files, we have to look at the foundations, to a man named Claude Shannon.
Everything we use today, from Wi-Fi to Bluetooth to 5G, is built on his math.
While working at Bell Labs, Shannon published his mathematical theory of communication, which established what we now call classical information theory. He was trying to solve what we refer to as level A, the technical problem of accurately transmitting symbols over a noisy, imperfect channel. But to make his brilliant mathematics work, Shannon made a very specific, deliberate choice. He explicitly decoupled the meaning of a message from the engineering problem of transmitting it. He essentially said, the meaning of the message is irrelevant to the engineering of the wire.
Under Shannon's separation theorem, a network treats a beautiful Shakespeare sonnet and a blast of absolute random static exactly the same. It doesn't read the poem, it just counts the ones and zeros and makes sure they match on the other end.
But literally a year later, a mathematician named Warren Weaver proposed a broader tripartite model. Weaver said, yes, Shannon's level A is the technical problem and it's brilliant, but there are two other levels we are ignoring. There's level B, the semantic problem. How precisely do the transmitted symbols convey the desired meaning? And level C, the effectiveness problem. How effectively does the received meaning influence the receiver's conduct in a goal-oriented context?
So level C is basically asking the ultimate question. Did the autonomous car actually stop before hitting the child? Not did the video load? Did the goal get achieved?
It's about goal achievement, not just symbol delivery.
If Warren Weaver laid this out in 1949, and it makes so much sense, why did we build 1G, 2G, all the way up through 5G entirely on Shannon's level A, leaving the meaning of the data on the cutting room floor?
Because the industry had absolutely no choice. The computational power required to mathematically extract and quantify intent or meaning simply didn't exist in 1950 or 1980 or even 2010.
Because it's a massive computing problem.
Huge. You can build a relatively cheap, simple electrical circuit to count discrete ones and zeros. You could not build a copper wire or a basic microchip that evaluates the philosophical intent of a photograph. Artificial intelligence, specifically deep learning and neural networks, is the missing computational substrate that finally makes Weaver's vision operational today.
And it's arriving exactly when we need it, because we're hitting a massive brick wall. The industry called it the Shannon limit, or the capacity wall. The sub-6 gigahertz spectrum is completely hopelessly saturated. And if we try to escape that by using much higher frequencies, we face severe physical propagation challenges. Those tiny waves get blocked by tree leaves, they bounce off buildings, they even get absorbed by heavy rain. We literally cannot brute force our way out of this data crisis by just finding more spectrum.
And you have to remember who these networks were built for. 5G was fundamentally human-centric. The ultimate gold standard test of a 5G network was streaming a pixel-perfect 4K video to a smartphone so a human eyeball could watch it without noticing a glitch. 6G is machine-centric. Machines don't have eyeballs. The machine's algorithm only needs velocity, trajectory, and crash probability. From Claude Shannon's rigid mathematics in the 1940s to the AI native architectures rolling out in the next few years, the core takeaway is clear. Prioritizing the transfer of meaning over the transmission of bits is the absolute cornerstone of the next era of global connectivity.
It's the only way forward.
It is the only mathematical, physical, and economic way we can scale successfully into the 2030s. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their strategic implications. Click the links below to learn more. Thank you for taking this deep dive with us. Keep exploring and keep asking questions about the hidden architecture of our digital world.